While all of the elements on the periodic table, and the periodic table itself, are very interesting, there is just one element that is of greatest interest for the time being: uranium. I'm positive that everyone viewing this has heard of the element uranium. However, many of you may only know one thing about uranium: it's radioactive. Other things and properties include that it is a silvery white metal. Its melting and boiling points are 1132 degrees Celsius and 3818 degrees Celsius, respectively. There are only 3 natural isotopes, but there are more that are man-made. All of them, however, are radioactive, and only uranium isotope 235 is fissionable and can be used to generate electricity. Historians note that uranium was first discovered by a German chemist by the name of Martin Klaproth during an experiment with the mineral pitchblende in the year 1789. But guess what? What he and the world thought at the time was pure uranium was in fact just a uranium oxide, and it was only first isolated in 1841 by French chemist Eugene Melchior Pelagot. Where was I? Oh, yes. By heating Klaproth's pure uranium in a platinum crucible. Now that we know some of its properties and a little history, we can ask, okay, where on Earth is it, and how do we extract it? The naturally occurring uranium isotopes are found just about everywhere. It is in the ground, water, air, and can even make its way into the human body. The amount that is in water is tiny, insignificantly tiny. Air's quantity is also tiny. Finally, the concentration in the Earth's crust differs from zone to zone. However, most areas are about 2.8 parts per million. Where uranium is mined, it can be 1,000 parts per million. And some mines in Canada have recorded at 20% uranium, or 20,000 parts per million. Uranium is mined just like many other rocks, minerals, and metals. However, just as if mining other materials, there are different types of mining as well. There is underground mining, which a good example of are salt mines and some gold mines. Other types include open-cut mining, which is not unlike many stone quarries. However, uranium mines are left with much waste rock instead of selling almost all the rock that comes out of the ground, as stone quarries do. There is another type of mining called in situ leach mining. Most mines blast ore which is loaded, hauled, and crushed. Crushed rock is then sent to a sulfuric acid bath, which dissolves uranium. Then the uranium oxide form is removed from the acid by ion exchange. In situ leach mining operates by relatively the same way, but because it derives uranium from sediment in water, it does not need to be crushed.
Good evening, I'm Jesse Rohrer. I'm standing on the parking lot at Sharp Shopper. It's Sunday evening, November 28th, 2010, 10:15 p.m. Now, you're probably wondering, why on earth should I care about uranium? I don't come in contact with it every day, and in saying this, you'd be very wrong. Why should you care about uranium? Do you like electricity? Do you like turning on your TV and other household appliances? Much of this would not be possible without the electricity generated through nuclear power plants. In fact, in 2009, approximately 20% of the nation's energy consumed was generated using nuclear fission. In 2009, nuclear reactors generated almost 790,000 gigawatt hours.
790,000 gigawatts? That's almost 1 gigawatt hour every 40 seconds.
Okay, so aside from power, uranium has many other uses. In military application, it's used in nuclear weaponry and in depleted uranium rounds like the one I have here. So, while you don't come in contact with significant amounts of uranium every day, you do come in contact with its product. It is there, and it is important in power production. But why am I wasting your time here? I have an experiment. So, if my calculations are correct, when this baby hits 28 miles an hour, you're going to see some serious stuff.